welcome to one and all. I'm Rohini Batwal from Bukli Education Society's JD English Medium High School with 8th standard, 4th chapter, that is current, electricity and magnetism. Can you recall, students? Which cells are used in modern equipments, for example in smartphone and in laptop? Correct, students. They are lithium-ion cells, and these cells can be recharged. Let us move towards the first topic, that is connecting cells. Students, you must have seen more than one electric cells connected in an electrical circuit. In the transistor radio, 2 to 3 dry cells are used to be connected in series. The purpose of doing this is to obtain more potential difference than that of a single cell. Therefore, it is possible to obtain high current. If the cells are connected as seen in figure 4.5b, the connection of cell is known as a battery of cells. See, students, in this series connection, the positive terminal of one cell is connected to the negative terminal of second cell, and the positive terminal of the second cell is connected to the negative terminal of the third one. Therefore, if each cell has a potential difference of 4, the total potential difference of 3 cells will be 3 volt. Use your brain power, student. You must have seen the car battery available in the market. It is called a battery and not a cell. Why? Let us move towards magnetic effects of electric current. See the activity. What we have taken, take the inside tray of an used up matchbox, place a small magnetic needle using the tray. You take a long connective wire and wind it around the tray. Complete the electric circuit by connecting in it this wire, electric cell, plug key and a bulb. Okay. Now mark the position of the magnetic needle. Take a bar magnet near to the magnetic needle. What do you observe? Keep looking at the needle and close the plug key. The bulb will light up and you will realize that the current has started flowing. Does the magnetic needle change its position? Now open the plug key. Does the magnetic needle come back to the original position? What will you conclude from this experiment? You know that a magnetic needle is indeed a magnet. You have seen that the magnetic needle changes its direction when a bar magnet is taken near the magnetic needle. Also, you have observed that the magnetic needle changes its direction when a current starts flowing in the circuit. This means that magnetic field is created when an electric current flows in a wire. Hans Christian Ørsted made this observation first. Now let us move towards electromagnet. See the activity. Take a meter long flexible copper wire having a resistive coating and wind tightly on a long iron screw. Connect the two ends of the wire in a circuit as shown in figure 4.7. Also connect an electric cell and a plug key in the circuit. Keep 2 to 4 iron pins small nail near the screw. Now start the current in the circuit by plugging the key. It will be noticed that the pins nails have stuck to the top of the screw. Will the pins nail continue to stick when the plug key is open? See, students, when the electric current flows in the wire, magnetism is produced in the coil around the screw, and because of that, the screw also attains magnetism. As soon as the current is stopped, this magnetism vanishes, that is, they stopped. The system of coil and screw is called an electromagnet. You have seen various uses of electromagnets in the 6th standard. Electromagnets are used to produce strong magnetic field useful in scientific research. Students, you have to draw the diagram. You have to draw electromagnet, magnetic effect of current, connecting cells, and last one is a electric bell. Now let us move towards the next, that is electric bell. Students, many of you must have seen the simple electric doorbell. Open such a bell which is out of order. See the figure in front of you, that is 4.8, depicts a bell with its outer cover removed. We see that there is an electromagnet inside. Let us understand the working of the bell. Means how it works. See, a copper wire is wound around an iron piece. This coil acts as an electromagnet. Why is it so? Because a copper wire is there on iron piece, so it works as electromagnet. An iron strip along with a sticker is fitted near to the electromagnet. A contact screw is in touch with the strip. The electric circuit is connected as shown in figure 4.8. The current flows in the circuit when screw is in contact with the strip, and hence the coil becomes a magnet and attracts the iron strip towards it. Therefore, the sticker hits the gang and the sound is created. However, at the same time, the contact screw loses the contact with the strip and the current in the circuit stops. In this situation, the electromagnet loses its magnetism and the iron strip moves back and come in contact with the contact screw. The electric current is then immediately restored and again the sticker hits the gang by the above process. This action repeats itself and the bell rings. See, this is the last part of this video, that is electric bell. I hope that you understood how the electric bell worked. Students, always questions come on this topic, how it works. So you have to go through this, you have to draw the diagram and read the lesson carefully. Students, here we have finished our whole lesson, and you have to write the difficult words, you have to write the definitions, and yes, you have to complete your exercise also. See students, whatever fill in the blanks are there, answers in the options are already given, that you have to choose and then you have to write. And rest of the answers you will get in the lesson itself. Let us see you again in the next chapter, that is inside the atom. Bye students, take care.